All right. Welcome everybody tonight for our presentation. My name is Adam Mahalski. I'm the Curator of Education at the Nevada State Railroad Museum here in Carson City. And thank you for joining us for tonight's presentation. How did they do that? Stories from the VNT Lyon Locomotive Replica Project. Just a few items first. I just wanted to mention that next month's program, the next program will be on Thursday, April 1st. The presentation is titled Transnationalism and the Transcontinental Railroad. This lecture will examine international influences and contributions to the construction of the Pacific Railroad, arguing that the story of the railroad is one of transnationalism. From immigrant workers, the clothes they wore and the foods they ate, to supplies and tools used to build the railroad, and emerging global networks made possible by the construction of the railroad. This presentation is by UC Santa Barbara PhD candidate and longtime NSRM volunteer, Christopher McMahon. And it should be an exciting program you won't want to miss. I just actually made the Zoom meeting for this presentation, so you can go on our Facebook page, our NSRM Facebook page, and you can find the link there. And I'll also be adding it to our website this week, carsonrailroadmuseum.org. So for tonight's presentation, if you have any questions, you can feel free to type them into the chat feature on Zoom, and then we can try to answer them as time allows or at the end of the presentation. So now it's time for tonight's presentation. How do they do that? Stories from the VNT Lyon Locomotive Replica Project by Todd Moore. Todd has been involved with the Lyon Replica Project for 15 years. He has served as a director of the Mason City and Clear Lake Electric Railway Historical Society while it oversaw the Lyon project, and was recently elected a trustee of the Friends of the Nevada State Railroad Museum, which assists the Nevada State Railroad Museum in furthering the Lyon project to eventual completion. Todd holds degrees in political science, history, and law from the University of Southern California. He is currently a practicing litigation attorney with Hahn & Hahn LLP in Pasadena, California. He has authored a two-part series detailing the history of the original Lyon locomotive and its reconstruction in the spring and summer 20 issues of the Friends of the Nevada State Railroad Museum's newsletter, The Sagebrush Headlight. So welcome, Todd Moore, to tonight's presentation. Thank you.
Thanks, Adam. I appreciate the museum's invitation. It's very good to be here and to talk to all of you about a topic that I think I have my paying job for, so that I can pursue my unpaid job of being a worker on the Lyon Locomotive Project. For those of you who haven't had the chance to read through the articles that give the background on the historic line, I wanted to take a minute and talk about what role the Lyon has in the history of the Virginia and Truckee Railroad, and then talk to you about how we made a few of the components of the replica Lyon project. So the original Lyon was built by the Union Iron Works of San Francisco in 1869. It was the first steam locomotive in Carson City. It was the first locomotive to pull a train into the Comstock lode. It was the first locomotive to pull a freight train on the Virginia and Truckee, but it was also one of the first locomotives that the railroad stopped using. There are a lot of great stories about the Lyon, in particular pulling the first train into the Comstock, and a very entertaining account that was published in the Gold Hill Daily News about Lyon and its train rolling across the Crown Point Trestle, which is depicted in the slide that you're looking at. Unfortunately, one thing that's missing is any photographs of the Lyon while it was running on the Virginia and Truckee. We recently, through the museum, commissioned a restoration feasibility report for the Lyon replica, and through the good efforts of Steve and Drew, we're able to discover this photograph from 1870. This is perhaps the only known photo of either the Lyon or its identical twin, the Ormsby, while they were running on the Virginia and Truckee. Now, if you look at this picture, you'd have to look very carefully to see the locomotive. But what we're looking at here is a photograph that's taken from the cupola on top of Nevada's state capitol looking toward the north. So that little dirt strip that kind of angles off diagonally in the photo is what we now call North Carson Street. The tall building on the left-hand side is what a lot of you now recognize as the former US Mint, now the Nevada State Museum. And right in the center of the photograph, you see a tiny locomotive. Now we're able to zoom in on that. And for people like me that have spent about 15 years staring at drawings and photographs of the Lyon while it was out of use, there's no doubt that the locomotive that's in that picture is either the Lyon or the Ormsby, its identical twin. The only other photo that we have where we know for sure it's of one of the first two locomotives on the Virginia and Truckee is this one. This is a locomotive, the Ormsby, renamed the Mountaineer for use on a logging railroad at South Lake Tahoe from about 1875 to 1879. So as you may notice, the tender is still lettered for the Virginia and Truckee Railroad. But other than that photograph, we really don't have a very good sense for what the Lyon looked like when it was in use on the Virginia and Truckee from about 1869 to 1875. But this next slide shows why after about 1875, the Lyon wasn't used. You can see that these are both the same wheel arrangement of locomotive called the Mogul or 260 wheel arrangement. This was the most common wheel arrangement on the Virginia and Truckee and on a lot of other railroads in the West. And this was the wheel arrangement that was popular for pulling freight trains. But you'll notice that the Lyon is significantly smaller than the Washoe that's depicted next to it. And the Washoe was similar to about 5 other Baldwin locomotives that had been ordered from the East. By virtue of being that much larger, those locomotives were capable of hauling much heavier trains. So smaller locomotives like the Lyon and the Ormsby were really not able to compete with that. So from about 1875 onward, the Lyon went into storage in Carson City in the old wooden engine house. And it really did reappear there for about a decade. So by about 1899, we think that the Lyon was scrapped. We do know, however, based on some recent research by Andrew Brandon, that the Lyon's boiler saw continued life in an industrial plant outside of Keeler in California and may have been used as late as 1924. So almost 100 years after the Lyon was scrapped, Stan Gentry of Clear Lake, Iowa, who grew up not too far from the Virginia and Truckee, got the idea that it would be a worthwhile project to reconstruct this pioneering locomotive from the Virginia and Truckee. Now, there were a lot of challenges in doing that. When you restore a steam locomotive, almost all the parts you need are there. They need to be rehabbed because maybe they're worn out, maybe they're broken, but almost the parts that are needed are already in existence. For a locomotive like the Lyon, not only are none of the parts in existence, but there really aren't any photographs to depict what it looked like when it was running on the railroad. But here's what we did have when the project started. So since Lyon was built by the Union Iron Works in San Francisco, one problem that was run into is, of course, the 1906 Great San Francisco earthquake and fire. That destroyed the Union Iron Works plant, and all but this single drawing of the Lyon from its construction paperwork were destroyed. This drawing currently is in the collection of the California State Railroad Museum, but it's been an invaluable artifact because it actually has dimensions for all the main parts of the locomotive. It's got a plan view so we can see how all those parts looked, and it gave us the main guide for reconstructing the locomotive. Now, after Lyon went into storage, it reemerged about 1887. So this is actually the earliest known photo of the lion. So the other one I showed you, we're not sure whether that's the lion or the Ormsby, but this is definitely the lion. And what's in front of the lion are all the pieces and parts of its identical twin, the Ormsby, which is in the process of being scrapped when this photo is taken. I can't tell you how many hours those of us involved in the project have spent staring at this photo, blowing it up to full screen sizes so that we can study each of the parts. But after about 5 years of staring at it, I feel pretty confident that I can identify every single pile of metal or every single item that's in that pile of metal in front of the lion's photograph. There are also about a dozen photographs of the lion in various states of disrepair around the late 1880s. So it was no longer stored inside after about 1887, and it spent a number of years on various sidetracks in the Carson City area. Here's one of the few views we have of the left side of the locomotive. And this is one of the few views that actually clearly depicts what the front of the locomotive looked like in its later days. And you see there that it's got a very plain front. And I want you to remember that because we're going to talk about that a little bit later on. So another invaluable piece of evidence about the original Lion is, believe it or not, the purchase contract between the Virginia and Truckee and the Union Iron Works still exists. It's part of the collection of the Railroad Museum in Carson City. It's got key elements about what materials the locomotive is made of, key dimensions. So that was another very important resource for us in reconstructing the Lion. So after years of synthesizing all that data, we're actually able to come up with this, which is a still from a three-dimensional model of the locomotive. This depicts one of the potential paint schemes for it. I don't know whether this will be the paint scheme that the museum decides to adopt or not, but it was one of the early ones that was being developed by Jim Wilkie and John Davis. And John Davis is actually the person that drew this really beautiful depiction of the locomotive. So once we had an idea of all the dimensions, we had to launch into making each of the parts of the locomotive. As you can imagine, a steam locomotive has thousands of parts, but I think the heart of a steam locomotive is the cylinders. That's where the steam that's generated by the boiler gets transferred into motion that turns the wheels. What you see in this slide is it's a 1800s teaching model, or could be as late as the 1920s, to teach students how steam locomotives work. That square over on the left-hand side is the cylinder. And you can see on the top, there are passageways to a valve chest, and that valve moves back and forth to admit steam and release exhaust to allow the piston, which is that gold-shaped T in the center, to go back and forth. In order to create the Lion cylinder, it involved hundreds and hundreds of hours of work, starting with drafting what the cylinders look like. Then it turned over to what you see here, which is the work of the pattern maker. So the Lion cylinders are cast out of gray iron, and that is a centuries-old process in which a model of the final part is used to create an impression in sand, and into that sand impression is poured molten metal. So when you're making a cylinder, it's very complicated because of its internal passageways. So you also have to have a sand mold of everything that's not going to be the cylinder. So the way to think about it is, when you're doing the pattern making, you're making a pattern for everything that is going to be the cylinder, and also everything that is not going to be the cylinder. So here you see, this is one of the workmen from the Strasburg Railroad that made the cylinders. he is actually shaping a sand mold piece that's being used for the passageways for steam to come in and out of the ends of the cylinder. So these are kind of a light color because they are coated in clay to help them release from the metal that's going to be poured into them. So now he's taking those pieces that he was just cleaning up and he's placing them inside of the negative impression of the cylinder itself. And now they're placing other things that we call cores, which in this particular instance, it's the core for the top part of the valve chest where all the steam is going to pass in and out. And then they're lowering the top half of the mold, which is sand, in the top half of the cylinder on top of it. This whole assembly probably weighs well over a ton. So this is being lifted by a large overhead crane. And then this is a photo of them pouring the molten metal into the mold. And you don't think about it, but everything in that mold has to really be weighted down quite a bit. Otherwise, that metal is going to make it float away. And you could have hot molten metal flowing all over the foundry floor. So after the metal is poured, it's allowed to cool, and then all the sand is broken off of the mold, and that leaves this. This is our rough casting of the cylinder. What makes it a rough casting is that it doesn't actually have any of the machined surfaces that things like the piston are going to ride on, and that the valve is going to go back and forth on. Those all have to be machined. All machining refers to is the process of using a large machine to cut away unwanted metal and to make it into a more finished surface. So here you see one of the Lyon cylinders attached to a machine to help face off one of the sides that bolts onto the Lyon's frames. What's depicted in this photo is an end mill. This is probably about 1.25 inches across, which is kind of like a drill shaped tool, but it's made out of very hard steel and is able to cut away the softer gray iron on the cylinder. This shows the top of the cylinder where the valves are going to travel after it's been machined. So you can see in comparison to the rough casting, this looks like a much more finished product. One of the more interesting parts is actually boring out the main part of the cylinder where the piston is going to travel back and forth. And I love this photograph for a couple reasons. First is you can see the Lyon's cylinder in the lathe where it's about to be bored, but you might notice that the casting isn't perfectly round. The weight isn't distributed very evenly. You see a lot of it is kind of off to the left side in this photograph. Well, in order to bore out the inside of the cylinder, that is going to have to be spun. The tool is going to be steady and the piece is what's going to be rotating. So if you'll notice on the plate that the cylinder is attached to, there's actually some chunks of lead that are attached to the side. And that's to act as a counterweight so that when this piece is spinning, it doesn't actually vibrate the machine into bits. And it makes it steadier so that the machining will be finer. So once all the machining is complete, one of the last steps in assembling or manufacturing the cylinder is called lapping. So on the top of the cylinder, a valve is going to go back and forth. And that valve is going to admit steam and release exhaust. It's very important on a steam locomotive that that be a tight seal between that valve and the top of the cylinder where the valve ports are. So the way that tight seal is achieved is a really old-fashioned way. So here you see one of the workmen at the Strasbourg Railroad that was assembling the chassis of the Lyon using what's called lapping compound. That's essentially a fine grade of sand mixed with oil. And he's just rubbing that valve back and forth by hand on top of the valve surface and grinding those two surfaces together so that they'll make a mating seal that steam is not going to blow past and interfere with the operation of the locomotive. So when we were making some parts of the Lion, we were very faithful to how they were originally made. So the cylinders of the Lion are made in almost exactly the same way that the Union Iron Works would have made them. Other elements of the locomotive are made in a different way. So what we see here is the cylinder saddle. So this is the part that both of the cylinders attach to that goes in the middle of the frame. And this is what's called the weldment. So this is a big part. It would have not been economical to make a wooden pattern of this part to have it cast as the original was made. So instead, this is made out of various parts of plate steel that have been cut and then welded together. But we take a lot of care with these parts to grind the welds so that the finished appearance of this part looks as much like a casting as possible. So here you see the completed saddle bolted onto the frame with the two cylinders. And I think if I hadn't told you that that was a weldment, so rather than a casting, you might not be able to tell. So that's the heart of the locomotive and how that was made. Let's talk a little bit about the wheels, which is what get this locomotive down the track. The wheel is a lot more complicated than it seems. If you were to go back and look at the drawing of the original Lion that survived the 1906 earthquake and fire, you would notice that a wheel of a steam locomotive isn't solid. The spokes are actually hollow, and it's got a lot of various components that aren't apparent to the eye. So remember, since this wheel is going to be a casting, somebody has to make a wooden pattern for everything that is the wheel and a lot of parts that aren't the wheel. Like every hole in the wheel has to have what's called a core box made so that a piece of sand can be used to put inside the mold so that when the metal is poured in, that hole is left behind. So once the wheels get cast, they have to be pressed onto the axle. So it might surprise you, but a steam locomotive doesn't have its wheels attached by like a weld or by bolts or anything like that. The way it's done is the axle is actually a little bit larger than the hole in the wheel. And so you use a giant tool, this is called a press, to press the axle into the wheel. So here we see the wheels being pressed onto the axles of the center drivers for the Lion. Here's the finished product. You can tell this is the center driver because of these parts. These are called the eccentrics, and they're an integral part of the valve gear. So remember how we talked about that valve that's moving back and forth and admitting steam and releasing steam? Well, that valve at times moves the opposite direction of the wheel, and that's achieved through these eccentrics, which are circles, but they're off center from the axle, so that as the axle is turning, the direction of motion can be changed. So that's what we use to make the valve go back and forth while the locomotive is just rolling in one direction. Another important part is when you have these wheels pressed onto the axle, they have to be what's called quartered. So there's a crank pin off the center of each one of the wheels that the rod's attached to, and those rods transmit the motion of the piston to all of the driving wheels, in this case, all 6 wheels. So here the center axle set is in a lathe, and it's having the crank pins quartered on the drivers. Now, you probably also noticed that there were no flanges. A really important part about a railed vehicle is it's got a flange to keep it on the tracks. Well, since the wheels are cast out of gray iron is strong, but it's not very hard. So if you had a gray iron wheel rolling down a steel rail or even another iron rail, it would wear out really quickly. So the way steam locomotives are built is there's a tire, but unlike a rubber tire, they have steel tires. So the steel is much harder than the gray iron, And that's put on in much the same way as the wheel onto the axle. But rather than using a press, it's very common to use fire. So think about when something gets hot, it expands. And when something's cold, it contracts. So the way tires are applied to steam locomotive wheels is there's a gas ring. You can see it. You see a little bit of the blue flame that goes around the tire, and then the wheel is kept cold. The tire expands by heat and it's slipped over the wheel, and then it's clamped in place and it cools, and then it shrinks onto the wheel and it makes a very, very tight fit. So here we see 4 of the 6 Lyon drivers that have their tires on them. And now this is a photograph that shows all 6 of the drivers. These are brand new back in January of 2000, and they're being united with the Lyon frame, cylinders, and cylinder saddle for the first time. So all these wheels are not connected in this photograph, but what does connect them are rods, and those rods attach to the crank pins through something called brasses. And the brasses on the Lyon are unique. They're actually a very bad design. They have covered ends, which in 1869, everybody thought was a good idea because they thought it would keep dirt out. So the Lyon's purchase contract specifies that all of the rod brasses will have covered ends. The reason that's a bad design is that in a normal steam locomotive, there's going to be wear on those brasses, and there'll be wear on the Lyon's brasses as well. But normally you would just drive a wedge and it would push the brasses together and take up the wear. Well, you can't do that on these brasses without taking them off the locomotive and machining away a small sliver of those caps, because it's the caps that keep the dirt out that keep the 2 worn pieces from getting snugged up closer together. Here's a photograph of the Lyon's rods as they're being manufactured, and you can see those brasses in the foreground of the photo, but they're upside down. So the covered part is facing the table and the open part is facing us. Another really interesting part of the locomotive is the boiler. And a boiler is pretty complicated in shape. It's got a round part in the front, and then for an early locomotive like the Lyon, it's got a square part in the back. That's the firebox portion. So that's where you burn the wood in the Lyon's case and heat the water. So the round part is very easy to make. There's a machine called a roller that can shape flat metal into a round shape. But when you make the transition from the round part to the square part, it requires a lot of handwork. So here we see some of the workers at the Strasburg Railroad using gas torches to heat up metal to form that transition piece. This is called the throat sheet. So they have to first make a mold for what they want the shape of the finished piece to be. They then heat it up, and then they beat it. And they beat it with sledgehammers. It's just through brute force. It can take hours to do this. So you would have people heating, and then other people coming in and beating it with sledgehammers. And that process repeats and repeats and repeats until the final shape is made. So here you see the throat sheet after it's gone through that process. So there have been many, many man hours hand forming this transition piece from the round part, which is here on the bottom, to the square part that you see on the top. Other parts of a boiler, even though they may be flat or they might be round rolled, still require a lot of handwork because a boiler is under a lot of pressure. The steam pressure for the Lyon is about 130 pounds per square inch. Even though the boiler is made of thick steel, it still has to be held in place so that the power of the steam doesn't overcome the strength of the steel. So here's one of the workers drilling holes for something called stay bolts. So about every 4 to 6 inches on any surface of the boiler, there are stay bolts to hold the two sides of a boiler together against the pressure of the steam. And here we see our transition piece attached to the round part of the boiler. And this is all a big transition, what we call course. So a boiler has a front course, a transition course, and then a rear course where the firebox is. So all these parts are being assembled. Now, unlike the original Lion, our new Lion's boiler is welded. The original Lion's boiler would have been riveted together, but it also would have been largely out of sight. It's a lot more cost effective and in a lot of ways safer and stronger to have this modern welded construction. So what we decided on the Lion is wherever the boiler parts are going to be exposed, we will replicate the rivets, but the boiler construction itself will be modern welded steel, but it will look to somebody as though it's like the original. So this photo of the boiler is missing the firebox portion. This depicts that firebox portion after it's being installed on the boiler. And what we're looking at is a cutaway view. We know from the original Lion contract, and we know from the Lion drawing that survived the earthquake, that it used an uncommon type of construction called crown bars. And what the crown bars do is they strengthen the top of the firebox. So as you can see in this photo, you've got the round top, and that round shape provides a lot of strength just by virtue of the fact that a circle is such a strong self-supporting figure. But the top of the firebox, which you see in the bottom of the photograph, is flat. So it uses essentially like a truss made out of steel to brace that top so that it doesn't collapse against the pressure of the steel. And as you can see, it's an extremely labor-intensive process to make that. There are literally hundreds of parts that had to be made from scratch to make those crown bars and to make a construction type that would be just like the original. And here's the boiler tilted on its side. This is a really interesting tool. You see here, this is called a magnetic drill. When you've got something as big as a locomotive boiler, you can't just take it over to a drill press and drill holes in it. So you have to bring the drill to the boiler. And what a magnetic drill does is it's got electromagnets in it. And once you turn them on, it's as though it's welded to that piece of steel. The magnets are so strong, and it holds it in place and allows you to drill accurate holes in the side of the boiler. So these are holes that are being drilled for stay bolts. So they're essentially bolts that are threaded all the way through, and they thread into one boiler sheet all the way through to the next and hold it together. So another major component of the Lion is the tender. I think a lot of us focus on the sexier part of a steam locomotive where all the work gets done, but you can't have that part do its work without a tender. That's what carries the water for the boiler and the fuel for the fire. Where you noticed on that drawing of the Lion, I've got a copy behind me, there is no drawing of the Lion's tender. All we have are photographs of the out of service Lion's tender to go by. However, there was one drawing of a different Union Iron Works locomotive tender that did survive. So we're able to call on that drawing for certain aspects, like how the frame of the tender might have been constructed, how some of the parts of the tender trucks or wheels went together. But as with the original Lion's tender, this one, the reproduction, has a wooden frame tender. And there's a really great story behind the wooden frames that you see here. These are actually all oak timbers, and they were cut in a steam-powered sawmill in Iowa. So Stan Gentry was building this with his family at their home in Iowa, and they used the local steam-powered sawmill to cut the timbers. So these timbers were hewn out of logs in much the same way that the original Lyon's tender timbers would have been hewn. This is the rear of the tender, and this is a Lincoln pin coupler pocket. So the Lyon went out of service before the modern knuckle couplers that our demonstration railroad uses today were even in existence. This is kind of an overall view of the timbers used for the frame of the tender. And these are seriously large pieces of wood, and they're all hand-cut mortises and tenons on them. Here's a view of one of the tender trucks being constructed. One of the interesting aspects of the Lyon is that it had leaf springs between the sides of the tender trucks and the bottom of the locomotive frame. So those springs would have rested in these two spring retainer cups. And on top here are the patterns that were used for casting those out of gray iron. And that's what one of the completed tender trucks looks like. You see it's pretty brightly colored. This is the overall view of, it's probably one of the first times the Lyon's tender saw the light of day at the facilities in Iowa. And then of course, there's a tender tank that goes on top of it. This was a very interesting piece of construction for anybody who comes to the museum today and sees this. For all intents and purposes, it looks like a welded tender tank, but it's actually not. This is a welded tender tank. Every single one of the rivet heads you see when you see this tender at the museum is actually a little rivet head that's spot welded onto the steel tank. I think my favorite part of the locomotive was the first one that I got involved in personally helping to make, and that's the builder's plate. You know, the builder's plate is a part that doesn't serve any useful function. It really serves as something that advertises the builder for all the world. It shows their pride of workmanship, and it serves as an advertising piece for the quality of their products. So here we see a zoomed in part of one of the photos of the Lyon when it was being stored outside. You notice there's a weird shadow in this, and that's actually where that builder's plate has broken. So probably at some point the Lyon had derailed, and this driver probably got pushed up against the fender that the builder's plate bolts onto, and it actually cracked it off. But that was important to know in replicating it because it gave us an idea about how this plate was attached. You know, you might suspect that maybe the plate was attached to the running board above, but if that were the case, when this part cracked off, it should have just fallen off the locomotive. But since it's still in place, we know there must have been some tabs that also attached the builder's plate to the fenders. We also have some clues about what this plate might have looked like from this photograph. Now you see it's the Union Ironworks, so they're obviously incorporating the motif of the Union stars and stripes. So you know, this is a locomotive that was built only 4 years after the end of the Civil War. So concepts like the Union would have been very near and dear to people at the time. So we can surmise from this evidence of what's likely white paint about how this may have been decorated. So based on our knowledge about where the Lyon's driving wheels were and where the running board was, we were able to determine what the dimensions of this plate would be. And then of course you have to draw it so somebody can make a wooden pattern. So Stan Gentry did a really great job of coming up with a drawing of the dimensions of this plate and every single one of these curves. And then what I did is I started with a piece of solid birch plywood, and I plotted out the center point of every single curve that makes up that builder's plate. And then I used a router, and I have a circle cutting jig for my router. And so you start the router off at the center point of every single one of those circles, and you trace the outlines for the entire inside and outside portions of that builder's plate. You'll notice, so this doesn't have any of the lettering on it. That's all separately applied. One of the things I learned by building the pattern for this builder's plate is just how complicated something as simple as a three-dimensional star is. So I have had some really great partners in this project, and my good friends Robert Lamont and Rory Hawkins spent almost an entire day in our working shop making a model of one of the 5 points of this star. Just the angles that are involved in this are really difficult to calculate, but we were able to use that single point to make a mold for casting all 5 points of the star. And so you see this disc that contains a urethane mold of the star that then got applied to the pattern. Now, when you look at this photo, you see that the lettering on it is pretty distinctive. And this is not lettering that you can just go download to your font packet on your computer and then print out and cut. Back in the 1860s, there would have been many foundries in San Francisco, and they would have bought letters from a foundry supply store. They would have been made from like a white metal, something that was easy to cast, and then they would have been nailed on to the pattern after the fact. Well, since this is such a visible part of the locomotive, we wanted to take a lot of care to get that lettering exactly right. So one of the things we did was we went to a place where we knew that there were a lot of pieces that were built by the Union Iron Works, and that place is Bodie. There are actually a lot of pieces of mining equipment that the Union Iron Works manufactured all the way through to the 1890s. And so Stan went to Bodie and took rubbings of the letters that were applied to the mining equipment at Bodie, and we used that to duplicate the font that we know the Union Iron Works was using on its castings to then hand draw and then hand cut the letters that were applied to this pattern. So this pattern gets used to make a negative impression in the sand, and then the iron is poured into it, and this is the casting that comes out. You might notice we've got those mounting prongs that we noticed from the broken builder's plate cast into this one. And sand molds are a little bit rough. You know, they look like the mold was made of sand, so you spend a lot of time smoothing out the raised surfaces that are really going to stand out on it. And then we spent a lot of time trying to figure out how might this piece have been decorated. So we knew about the white paint that was evident on the old one, so it made sense that that's probably imitating the red and white stripes of the US flag. And then what is next to the red and white stripes of the flag? Well, there's a blue field. So we surmise that it might have been likely that all this recessed portion would have been blue. And then we went through a lot of different debates and designs about what these other raised portions would have been like. Would they have been white? Might they have been painted yellow? What we eventually settled on is we thought that the builders probably would have wanted this part to really pop. So we put gold leaf on it. And I think it really makes it almost as beautiful as any other builder's plate around. You know, I think I would put this builder's plate up against the really beautiful plate that's on the Inyo, which is cast brass. Now, we know, however, that the Lyon didn't have a cast brass plate because brass probably would not have cracked like the plate cracked in the photograph that we see of the Lyon. So more than likely, we think Lyon would have had an iron plate, but it would have been decorated to make it really stand out. So we've ended up with the design that you see depicted in this photo. So another key part that goes along with the valve chests of the locomotive, or rather the cylinders of the locomotive, are the valve chests. So you may recall that in the drawings or the photographs of the valve, or this of this cylinders rather, the valve area is exposed. Well, that has to get covered by a valve chest. So we were able to determine exactly what the valve chest looks like, even though it's typically surrounded by a decorative wrapper, because those valve chests were visible in that photograph of the Lion next to all the parts of the Ormsby that are being scrapped. So let me show that to you. So the valve chest is right here. Can everybody see the cursor? So we know that this was an uncommon design of valve chest, whereas most locomotives have bolts that hold that chest in place that pass through the casting. We can see in this image of the Ormsby valve chest that the Lion had a different design in which the bolts all go around the outside of the valve chest. So let me scroll ahead here to back to the photos. So here's our cast valve chest on the mill, getting the hole drilled for the stem that guides the valve. So that's going to be passing in and out. So the motion of the valve is back and forth. So you need to have a hole for that rod that moves the valve that's going back and forth. And then here we're using a boring bar to make a drilled hole bigger. This is a really labor intensive, slow process. You're taking about 50 thousandths of an inch off at a time. So that hole is getting ever so slightly larger with each pass. And then when that hole was made, we are here carving a channel for the gasket. So today we have a lot of materials that make great gaskets. You know, they're composite materials. A lot of times they have a paper base with composites added to them, and it's really easy to make a new gasket by cutting it out. In the 1860s, they used copper for making gaskets. So copper is a metal that once you heat it up through a process called annealing, it becomes very soft and pliable. So here we're cutting a little channel around the top of the valve chest for a 1/4 inch rod of copper to rest. That'll be annealed, and then there'll be a top plate that goes on top of this chest that gets clamped down, and that copper will squish down and make a steam tight seal. So we drilled that hole in the valve chest. We need to have a packing gland for that valve to go through. So what a packing gland is it holds like a rope-like material around the stem that's moving back and forth to keep steam from leaking out. So in order to keep the steel rod from wearing out against the iron packing gland, we machined softer bronze linings for that will press into these parts, and they'll allow those linings to wear out, which these linings are not that hard to make, but the valve stem is very hard to make. So we want to wear out the easy part, not the hard part. And so here you see the final assembly of the packing gland in the valve chest. So you see we press that bronze liner in place, and now it's ready. And being proud builders, we left our mark inside. So we have a little machine shop down in Burbank that we kind of jokingly call the California Locomotive and Iron Works. So we stamped our name and the date that we did the work and V&T Lyon on the inside of the valve chest. So nobody will ever see it, but we'll know it's there. When I think of the Lion, I think the most remarkable part of it is that enormous smokestack. And when I got involved in the project, I pretty early on decided that I wanted to be part of making that. And so the patterns for the base of the smokestack made their way to my home, which at the time was in Southern California. And I searched around for a foundry that would be willing to cast a one-off piece for a steam locomotive, being this base for the smokestack. So here it is. It's in my little tiny crossover utility vehicle. I think this piece weighed about 500 pounds. So I think my suspension was probably pretty close to bottoming out at the time. But the major part of the smokestack is the sheet metal. Well, I think when you're going to build a smokestack, probably your biggest fear is that it's going to come out crooked. And if you were to build the smokestack right side up, it would be really hard to make sure that you had everything concentric. So you've got the bottom part, which is the widest, or the top part, which is the widest, and the bottom part, which is the narrowest. So the way we did it was we drew a circle that we could line up all the metal to, and then another circle for the top. And then we hung a plumb bob from the top piece to the center of the bottom circle, and we could make sure that the two circles were exactly concentric so that the smokestack would not be crooked because the circles weren't concentric. Then we had to hand drill every single rivet hole on this. So once we had all the pieces correctly in place, we hand drilled out all the holes. And then the way the riveting process works is you install a nut and a bolt in every single rivet hole. And then when you're ready to rivet, you withdraw the bolt and the nut and you place a in. And then one guy is on the outside holding the head of the rivet in place, and another guy is on the inside hammering over the head of that rivet so that it makes a solid joint. And that was pretty easy when we were working on the upside down bottom part of the smokestack. But when we worked our way to the top, which was the bottom for our construction purposes, the guy on the inside had to be turned upside down and hammering upside down in order to turn over the rivet heads. So here you can see those rivets. I don't think we ever counted how many rivets are in this smokestack, but I would say we probably spent 3 or 4 months worth of weekends and weekday nights drilling holes, bolting them up, and then hand riveting every single rivet on that smokestack. And this is me and my friend Rob Lamont and Rory Hawkins standing next to what we are going to die claiming is the world's largest steam locomotive smokestack. So there is not a Guinness Book of World Records on it, but we're laying claim to it. Now, I learned that there are a lot of parts to a smokestack that you cannot see from the outside. And since we were building an operational locomotive, we had to build those inside parts. So there's actually another smokestack inside of this one, which is a straight tube. And on top of that is what looks like an upside down sombrero. So when smoke is being ejected from the inside smokestack, it hits that sombrero, and all of the cinders that are a fire hazard come up, they hit the sombrero and they go down, and they actually collect inside this big funnel. And so this is a giant spark arrestor, really, in essence. But on top of it is kind of the last ditch effort to keep burning embers out. There's a big piece of screen. So we had to design that screen. So this is my hand-drawn plan for how we were going to go about constructing the screen for the Lion. So there are some tricky parts which we drew details of so you could see how the various components have to go together, because we're dealing with some really small spaces where we don't have any room for error for these parts to go together. So you really have to think every single part through very carefully. We are not locomotive geniuses, so we rely on other examples of locomotive construction. And the prototype that we looked to for the Lyon's smokestack top was the Glenbrook's smokestack, which is another locomotive at the museum. So the Glenbrook's original smokestack screen is actually still at the museum, and we made drawings and a careful study of that, and we used that to design the new one. So here you see that frame starting to take place. Every single part on this is handmade. So every one of these ribs is hand bent according to a wooden form so that we can make sure that they're all uniform. And all the screen pieces are all hand cut and hand formed. And there you see the completed screen. So this is almost 4 feet across. So it's a pretty big piece of metal. But one interesting part is, in talking to Chris DeWitt, we discovered that if we ever wanted to run the Lion over land that was controlled by the federal government, there's actually a federal government standard for what size this mesh has to be in the screen. So thank goodness we learned about that before we built the screen. So now the Lion has a completely federal government compliant smokestack. Now, this smokestack sits next to the front of the locomotive. It sits on top of what we call the smoke box. Here's the smoke box on one of the Union Iron Works locomotives that was built around the same time as the Lion. This is the Ralston. It was built in 1870, so the year after the Lion was completed. And you can see it's got a pretty fancy front. And all the photos that we see of the Lion, of course, are taken after it's pretty well worn out. It's at the end of its service career, and it's got a very plain front. So we explored, well, what did other Union Iron Works locomotives built before Lion? What did they have for the front of their locomotives? And we discovered that they had fancy fronts, just like the locomotives that came in the year or two after the Lion was built. So we then tried to do a dive through the available Virginia and Truckee maintenance records, and we discovered that the Lion underwent major repairs a couple of times, and one of those times was due to an accident that greatly damaged the front of the locomotive and in fact swept off the smokestack of the locomotive. So we were able to conclude that more likely than not, Lion originally had the more fancy front that we see in other Union Iron Works locomotives, but due to an accident it got into later on in its life, it was replaced by the Virginia and Truckee with a much more plain front. So as a result of that, we came up with this design. So these are actually the castings that we made. This piece is huge. It's about 4 feet across. This door is very, very heavy. I think the casting came out too thick, to be honest with you, but we're looking at several 100 pounds of metals here. And just as we saw in the other ones, it would have said H.J. Booth and Company Builders, and then had the place of construction, the year of construction on the bottom. Now, since we decided to bite this off at our little machine shop in Burbank, we didn't really have the best tools for machining this, but we made do. Here you see where we have the whole assembly where we are machining out the door hinges so that we can mount the door on the ring. And it's on our regular size Bridgeport mill, but the piece is so heavy, it would have damaged the mill if we just let it hang out like this. So we actually have our shop crane helping take some of the weight off of our mill. I highly don't recommend this type of work, but when you can't afford the giant machine tools that a big full-time railroad shop has, you've got to make do. And this is the finished product. I was very happy with how this came out. This is a very much older style of smoke box, which would have been indicative of locomotives that you might be familiar with, like the Jupiter, one of the Central Pacific locomotives that was at the driving of the Golden Spike. So it actually has a handle here on the bottom that has a mechanism that's hidden behind the number plate. So you turn the handle and there's a locking mechanism that turns and it withdraws prongs that lock it against the smoke box ring around the outside so that you can swing that door open. So once we had all these parts, they were being made all over the country. You know, the boiler and the chassis were begun in Pennsylvania, but the boiler eventually went off to Chicago and was completed by Dave Clokey at his shop there. The smokestack was built by me and my group of friends in California, and we would ship parts to Iowa, but it was very difficult for all of us to get together and actually see all of the parts of the locomotive that we had made together. But fortunately, you know, we were able to do that in Iowa once, and then when the locomotive, of course, arrived in Carson City, we were able to unite all the parts that we have made so far in what I like to call the Lyon's new forever home at the Railroad Museum in Carson City. So this gives you an idea of kind of the size of the locomotive. So that's me. Kevin Owens is running the skylift, and we're placing the smokestack on the locomotive for the first time in Carson City. And here you go. I love this view because it starts to give you more an idea of what an elegant piece of machinery the locomotive is going to be. It's got that really delicate looking pilot that a lot of people call a cow catcher. So that's to get objects out of the way. And of course, you got the beautiful brass number plate and that imposing smokestack. And one day, of course, we'll have that really beautiful builder's plate over the drivers, and then a really nice wooden cab and nosing on running boards and a nice brass bell and all that. I think it'll be a really nice representative and ambassador for the museum. And that brings me to one of the last things I wanted to talk about, which is how does the Lion fit in with the Nevada State Railroad Museum? Well, I think first and foremost, it will represent one of the very few locomotives from the 1860s era that's able to operate and interpret that style of railroading. And we've been building the Lion so that it will, in its outward appearance and its operation, be just like the original. That goes right down to the safety valves on the locomotive. You know, today's steam locomotives, the safety valve goes off and it's a big pop and a giant plume of steam comes out. But the Lion had a completely different setup. It had what's called a spring balance to hold the pressure in the boiler, and the release of steam was very slow and a lot less dramatic. And so we'll be able to represent that. But I think another equally important, if not more important, value of the Lion is helping to extend the operational life of the museum's artifacts. You know, a steam locomotive is a machine that wears itself out. The more you operate it, the more it wears out. One of the distinguishing features of the Nevada State Railroad Museum is that most of our artifacts are in operating condition. So you can come out and you can see the Inyo running. You can see Virginia and Truckee number 25 running. You can see the Glenbrook running. But the more we run those artifacts, the more we're wearing them out. You know, there will come a day when if we run the 25 for decades more, it will need a new boiler. It might need new tires. It might develop a crack in a driver that might need to be replaced. So while we love running our equipment at the museum, it's always been the museum's intent to have a locomotive that is the one that provides most of the motive power for the rides that we give, so that we're not using our precious artifacts to haul passengers. And that locomotive used to be the number 8, but as I think a lot of you know, the 8 had to be retired in 2008 due to the fact that it's just simply worn out. And now we're using the 25, and the museum's done a great job of keeping the 25 in good condition. But it will wear out one day too. And rather than have to replace a lot of the historic material on the 25, it would be a lot better for the museum to have a locomotive like the Lyon, which is brand new, to be able to shoulder a lot of that load. And none of the parts on the Lyon are historic artifacts. So if something wears or it breaks, we already have the patterns to make a replacement, and it's no great historic loss if that occurs. The other thing is to have a brand new locomotive for the museum really ensures that we've got a long-term future for having an operating demonstration railroad. You know, right now we're one major breakdown in the 25 away from not being able to give people steam train rides. So to have an operating Lyon gives us a lot more flexibility, not only to have a non-artifact pulling their trains, but to also just have a backup in case something goes wrong. Last is the Lyon, because of its small size, actually can be pretty easily trucked around the country. It doesn't require special expensive permits to be taken to various rail festivals or to visit tourist railroads. So this is a locomotive that really has the capacity to be the face of the Nevada State Railroad Museum in Carson City. It's something that we can take to rail fairs, that we can take to tourist railroads to attract people to our museum and to really increase its profile everywhere. But we're not done. And we estimate that it will cost anywhere from $250,000 to about $400,000 to complete the Lyon. As it stands right now, it's about 80% complete. So it's very close to being able to be steamed, but there are some expensive parts that have yet to be made, like the sand dome, the steam dome, a lot of the gauges that will go inside of the cab, and of course the cab itself still need to be constructed. But if you were to commission the construction of a new replica locomotive today, it would cost the museum or anybody else well over $1.5 million to do that. Some of the more recent locomotives like the York or the Leviathan, those are in the millions of dollars to construct those. So the fact that the Lyon has been donated to the Nevada State Railroad Museum is akin to getting over $1.5 million donated to the museum. So it's got a great running head start on completing a locomotive that I think most other museums just would not have the resources to be able to even undertake. So how can you help with that? Well, I'm going to ask Adam to post in the chat a link to the Friends of the Nevada State Railroad Museum webpage. We've got a secure online donation portal where you can give as little or as much as you like. We're also going to be rolling out, hopefully within the next couple of months, a subscription service so that people can give like the cost of a coffee every month toward the project. You can subscribe for $1 a week or $5 a month, whatever you decide, and you can become a sustaining sponsor for the program. Another thing you can do is, we may have woodworkers out there in the audience. They might be able to contribute their skills in that regard, or even somebody who's a photographer might be able to donate photography skills that we can use in advertising the project to others. So no matter what your skill is, there's probably some value that you can bring to this project that we would love to use and to help us with. And another important thing is, a lot of you are also involved in other museums or other preservation efforts, and we'd love for you to help us identify grant opportunities. For every historic preservation or reconstruction project, usually well over half of the funding for that project comes through charitable grants. And there really is not a central clearinghouse for identifying those grants. We really have to rely on people telling us what they know about so that we can undertake the effort to apply for and hopefully get those grants. So that's what I wanted to share with you. Yeah, there are many, many parts that I was not able to talk with you about, but I'm happy to take any questions or have any comments. So I'm going to go ahead and stop sharing my screen. And if there are any questions, let's see.
Yeah, it looks like we have a question from Bob Thomason. It says, Todd, you mentioned using a California machine shop and a California foundry. Can you tell us what machine shop and foundry you used?
Sure. The foundry we use is called Covert Ironworks, not because it's secret, but because it's owned by a guy named Ken Covert. That's a foundry in Southern California. We use that for the smokestack base, for the a lot of the covers that we made. The builder's plate, the other Lyon builder's plates behind me, if you see my video, those were cast at a different foundry in Los Angeles that unfortunately is no longer in business. The machine we used was a machine shop that I'm partners with my friends Rob and Rory. So we have a pretty well-equipped shop down in Burbank, and we did all the machining ourselves for that. So thanks for that question, Bob.
Right. Thanks. We have another question from Jonathan O'Clair. He says, I have a few photos and videos I took of Lyon when it was still at the Iowa Trolley Park back in July 2019. Would these be of any interest?
Definitely, Jonathan. The museum is not only studying and documenting the historic Lyon, but we're also trying to do a good job to document the reconstruction of the Lyon. So when the locomotive was in Iowa, yeah, that was an important part of its history. And we'd really love to have your photos and videos. I think the best place to send those would be either to Adam, or you could send those to Wendell Huffman, who's the curator of history at the museum in Carson City and is compiling all the documentation of the project.
Okay, I just put my email address in there in case if you'd like to send me those photos, we'd be happy to take those. And we can put them in our collection with our Lyon materials. So thanks, Jonathan O'Clair. From Alex Mayer, so you said that this engine was wood burning. Were all types of wood used or certain hardwoods?
That's a good question too. So the Virginia and Truckee locomotives would have mostly used local woods. So they would have predominantly been burning pine. They would have been burning ponderosa pine predominantly. That would have been flumed down from the mountains above. It's interesting though, I learned in the course of researching the Lyon that back in the day they studied wood, and they wanted to make sure they had the best, hottest burning wood. And the hottest burning wood that they determined was pinyon pine. So we know today that the hills around Virginia City were covered in pinyon pine. That pretty quickly got exhausted though. So probably the Lyon mostly would have been burning the longer needle pines from the Sierra Nevada, because that pinyon pine would have been mostly gone from the local area by 1869. But hardwoods are actually not a very good choice for a steam locomotive. They're a great choice for a fireplace because they burn really slowly. And so they make a good, pretty fire for a long time, but they don't really burn as vigorously. And that's really the most important part in a steam locomotive, is a good, vigorous fire that's going to keep up with the steam demands of the locomotive. So,
all right.
Any other questions?
I was just kind of curious as to how you got involved with the project, or just like what drew you to this project.
That's a really interesting story. So like a lot of you, I've been going to the V&T Railroad Historical Society symposia for a while. In fact, I made my dad take me to one in 1979 when I was 8 years old. So this is a lifetime affliction. But I went to one in, I think it was 1996, and Stan Gentry was speaking there. And I had heard all these rumors about some crazy guy in Iowa who was building a replica of the first Virginia and Truckee locomotive. And I just thought, okay, he's probably making drawings and maybe he's building a model of it or something. But I got there a little bit late when he was speaking, and I sat down at a table in the back, and it was just me and Stan. And I got to meet him before, talk to him before he got up there to speak. And then he spoke and he showed us photographs, and you could see that he's actually building this thing. And there were major parts of it done, and it wasn't just a crazy dream, it was a crazy real project, and that someday it was going to be a real locomotive. And I was hooked from that point. And I asked him how I could get involved, and we had already formed our machine shop in Burbank, and I offered that I would help with that. And just over the years we've made probably, dozens of parts for the locomotive. When I first got involved, I would say the Lyon was about 50% complete. So, we've done about 30% more of the project. And, we had to figure a lot of things out, a lot, like how a lot of components go together and what are the best materials. And, fortunately, we've had a lot of people to help us along the way. Some of them are on this Zoom meeting, but it really takes not just a village of people, but an army of people to successfully build a steam locomotive. So I'm really grateful to Stan for launching this project in the first place, because I don't think anybody else would have been crazy enough to build a steam locomotive from scratch. And then to everybody who's pitched in to bring this so close to chugging down the track.
Great, thank you. We have a question from Daniel Osborne. What are your plans for the appliances, the lubricator, injector or water pump, etc.? Can I assume the boiler has been annealed and x-rayed? Are there tubes in the boiler?
All right, I actually can answer all those, so I'm happy. So the plans are, we're going to have the original style of lubricator. It would have required the firemen to periodically go out on the running board of the locomotive and fill a cup above the valve chest. So we're going to have those, but we also don't want to die while we're chugging down the track. So we are also going to have a more modern hydrostatic lubricator inside of the cab of the locomotive. The Lyon, as far as injectors go, when it was in railroad service, didn't have injectors. For those of you who don't know, an injector is a device that uses the combination of steam and water to put the additional water into the boiler. The Lyon had crosshead pumps. So it had a pump that used mechanical motion of the locomotive to add water to the boiler. That's very problematic for a locomotive like the Lyon, which may spend a lot of time on display sitting, because a crosshead pump will only add water when you're moving. So we're going to have at least one injector on the locomotive that will do as good a job as we can to try to hide that injector, probably in the cab of the locomotive, so that from the outside, it still looks authentic. As far as the boiler, yes, the boiler, all the welds have been heat treated, so they're stress relieved, and they've all been x-rayed. It's a completely modern FRA, meaning Federal Railroad Administration approved boiler. All the documentation for every piece of metal in that boiler has to be kept, so that if any railroad were willing to host us, we could run on it and be compliant with the Federal Railroad Administration rules. So we could double head the Lyon with the big boy someday if Union Pacific wanted us
to. I'd love to see the Lyon and the big boy double heading up Sherman Hill. Pretty awesome.
You might have a real hard time seeing the Lyon when it's shrunken and hidden by the big boy. I asked those questions, Todd, mainly because I've been part of a restoration project of a locomotive, and things that the brass were all stripped off, the lubricator, etc. Uh, and I'm aware of the problem of it. The Lion was built before injectors were invented almost. And so having a locomotive having to run up and down the tracks just to put water in the boiler is not fun.
Yeah, if we're ever going to be at a rail festival with a big crowd, we're going to need to add water while we're standing still.
You may want to put 2 injectors in. I don't know what your boiler codes are like here in this state, but it's always useful to have 2 because injectors sometimes do funny things.
Yes, as a longtime volunteer at the museum, I can testify to the fact that they're pretty bulky.
Well, you have to have cold water going into them.
Yep, yep. Yeah, good point. So I see there's a question from Taylor McCready about air brakes.
Yeah.
Yes, the Lion will have air brakes, not on the locomotive drivers though. There were never brake shoes on the locomotive drivers. The tender brakes, originally there were hand brakes on it, so we will have those be able to interface with air brakes, and then we're going to be hiding a small air pump on the locomotive as well so that we can power air brakes, because that's a pretty important part of safe operation in demonstration railroad purposes. Definitely. Good question. I can't tell you which type of air brake stand we're going to have.
Also, there's another question from Jonathan O'Clair of the new parts that Lion will need. How many can be used from refurbished existing parts, and how much will be built new?
That underscores a really great point. It doesn't have any refurbished parts, so every part on the Lion is made from scratch, and that is one of the big difficulties of the job. You can't just take the Lion's pilot from somewhere else. It has to be designed, and then it has to be built from scratch. So every part on that locomotive is original to that locomotive. Yep. Now I noticed Stan Gentry is actually in this meeting. So Stan does not love public speaking. So, but I know that he would love to answer questions if anybody had them. So feel free to direct any questions at Stan, and we'll ask him to unmute himself and chime in.
Well, hello, Todd. I think you did a fantastic job.
Thank you, Stan. So nobody's going to question Stan's sanity for building the Lion or anything like that?
Well, it's already been decided. He was insane.
You want to tell everybody why, among all the V&T locomotives, you chose the Lion?
I chose the Lion, well, not one because it was Union Iron Works. You stated most of the things. You did a very good job. But that it was a Union Iron Works locomotive, number one. Number two, it could be trailered quite easily. And that there was no other locomotive like it specifically in existence. There were the moguls you've talked about, but the specific locomotive, there wasn't another example, and definitely not another example of the Union Iron Works work.
Yeah, I think it'll be interesting because there are no, as far as I know, there are no existing Union Iron Works locomotives available or in existence. So I think this will be kind of cool to have a replica of a Union Iron Works locomotive, and one that would work, one that would be operational. So I think that's a really cool replica to have here at the museum.
There are several of us that I think it's fair to say we have tried to scour the earth trying to find any parts of Union Iron Works locomotives. We think there may be cylinders for a couple of narrow gauge Union Iron Works engines that still exist in El Salvador. They were used as part of the machine shop for one of the early railroads down there. We think those might still be in existence. Our organization, the Iowa Trolley Park, we actually have a tender tank from a Union Ironworks locomotive. We think it was either the Inyo or the Mono from the Bodie and Benton Railroad. So we're preserving that undercover in Iowa so we can find its forever home, hopefully back closer to its original line. But other than that, that's the only parts that we know of Union Ironworks locomotives. I have personally been told by about 3 different people that they had the headlight from the Lion. So yeah, that they can't possibly all be right, but it is possible that the headlight of the Lion got recycled at some point. I also think since those builder plates, like the one behind me, are so unique, maybe there's a barn in Carson City that has one in it. So Stan and I actually talked about that. We kind of hope it never shows up because we don't want to find out that maybe we got something wrong. But in case we got it exactly right, there's a couple of secret things on the builder's plate that can be used to tell it from an original. So that's actually something we try to be cognizant of, is that, if someday some part of the Lion should show up, how will we know that it's not a fake? And it's interesting, from time to time, we sold a few of the builder's plates to raise money for the project. They'll come up for sale on eBay or other sites. And I really love to read the descriptions that people put in, because its origin is getting more and more wild over time. As these sales go on, the piece gets older and older, and it gets closer and closer to being an original. So probably by the time I'm even more bald and more gray than I am today, people will be selling original builder's plates of the Lion.
Yeah, there'll be multiple builder's plates, and yeah, we won't be able to know which one's the original.
Well, I'll tell you my secret, Adam. So
I have a question for you. Is on a lot of locomotives, there were parts made from standard manufacturers like the headlight. The locomotive manufacturer didn't make headlights. He bought them from a vendor and put them on. So it's maybe possible that several people have headlights that look exactly like what was on the Lion, and may have come off of any locomotive of the same period.
Yeah, that's a good point. And we know from the Lion purchase contract copy that's still in existence that it did call out a particular manufacturer of headlights. So it's a Williams locomotive headlight. So yeah, that was pretty common, and not just used for locomotives, but used for a variety of purposes, just to light up areas at night. So there are a lot of those floating around that probably have nothing to do with the Lion. But it's also interesting that contract calls out particular manufacturers for other parts. And for years, we kind of puzzled over this one reference that said all brasses to be Garrett brasses. And we just thought, what the heck does that mean? And Stan ran across a really nice whistle that was made by W.T. Garrett and Sons, a famous brass foundry in San Francisco. And sure enough, they were right next door to the Union Ironworks. They were very well known to anybody in the West who was acquiring brass products. So the V&T wanted to have the best brass on their locomotives, so they called out for brass from W.T. Garrett and Sons in the contract. It just took us 100 years later to figure out what that meant.
Is that Garrett and Sons? Is that still around too?
No, unfortunately, it's not. There are a lot of Garrett products that still are in circulation. They made a lot of the school bells that you'll find in old buildings in Northern California and Northern Nevada. We think that they probably made the Lion's locomotive bell. Some people think it's possible that the Lion's bell became the depot bell for the Carson City Depot, because that depot bell showed up at around the same time the Lion's usefulness was run out. And so, yeah, it is possible that they took a bell off one of their stored locomotives and put it on their depot, but we don't have anything other than just the coincidence of that happening to prove one way or another. So.
Okay. We have a few more questions. Sam Flakus has a question for Stan. He wants to know, where near the V&T did you grow up?
I grew up in Colville, California, or Topaz, California, more specifically. But went to school down there, and we played 6-man football all over the state of Nevada, and you know, it was a good life.
Great, thank you. And then Alex Mayer, so I assume that a boiler jacket is still needed. If so, will it be one molded shell or riveted together with brass? Or
Well,
brass bands hiding the joints, sorry.
Yeah, so we actually do have the brass bands for the boiler already. We do not have the exterior cladding for it. I'm hopeful that one day Chris DeWitt from the museum is going to try to replicate the process that Russia iron was made. So Russia iron was a product that isn't available anymore. It was basically a form of carbon treatment or the surface of steel that gave it some protection from the elements so that it wouldn't rust so easily. And it resulted in kind of a metallic but somewhat bluish finish to the jacketing. And Chris has been right there at the forefront of a lot of efforts to try to understand the process by which that was made. It's called Russia iron because it was made in Russia. And so we don't have anybody in this area that has any familiarity with that process, but we think we understand chemically what Russia iron is. And from a few accounts that have been discovered over the last couple of decades, we think we understand generally the process that was used to make it. So I know that Chris is going to attempt in the next couple of years to duplicate it. And our hope is that the Lyon will be, if not the first, one of the first locomotives to get that replica Russia iron jacket rather than paint or bluing like a lot of boiler jackets on steam locomotive restorations have today.
Great, thank you. And we have another question from Matthew Mollendorf. Do most of the people in restoration have relevant job skills such as machinists, etc., or can anybody help out?
Well, I can tell you that when I started, I didn't have any skills in any of that. I'm a lawyer, so you don't learn very many steam locomotive construction skills in my line of work. So I learned from people who know a lot better than I do about it. But there were a lot of lessons I learned the hard way. Like I have a funny story. I went to a sheet metal shop when we were building the smokestack because we needed to have a piece of L iron that was a long stick. We needed to have that rolled so that we could rivet it inside the top of the smokestack to hold up the basket. And so I told the guy what I wanted, and he told me, well, do you want that rolled the hard way or the easy way? And I thought, are you joking with me, or is that an actual term? And it turns out that's a term of art for how the angle is rolled. Is it angled with one side shrinking or one side being stretched out? So it's hard to shrink metal. It's easy to stretch it. So whether you're shrinking or stretching the metal, they call that rolling it the hard way or the easy way. So I learned the hard way, that part of technology. So there are just constantly new things to learn, but that's what makes it exciting. As long as you've got a willingness to help out, I'm sure we could put you to work. We're hoping that, in the post-COVID world, we're going to need people to help us with a lot of projects on the locomotive, not the least of which is just getting it cleaned up. So you don't have to have special skills to clean something. So if you want to help out, let somebody at the museum, probably Adam, know, and he'll pass it along. And when we get those work parties together, when it's safe, we'll be happy to have you out.
All right, thanks.
I got
Um,
one last question.
Yep, go ahead.
Have you considered using any of the modern technologies like printed, 3D printed metal for some of the smaller parts that'll be expensive to cast, but maybe cheap because you're only doing them one-off, which is right up the alley. And in lieu of that, also, the University of Nevada Engineering School, maybe that could become a great student project for them to put together for you and save you both money as well as getting a great part.
That's a really good idea. That's definitely something that we'll pursue. I know that what we're really looking at for 3D printing is to help us make patterns for smaller parts. That's a great time-saving way, and we've got some people like Taylor, who's on this call, who's a whiz with 3D slinking out of the picture. He's a real whiz with 3D modeling. We can use people like that to help us come up with drawings that we can then feed into a computer-aided machining program and 3D print a pattern that we can use for casting parts. So, Taylor, I didn't mean to make you go away there. Sorry.
And then also just a general question, is there a way to watch the recording? Yes, I will be putting this, I think on YouTube, and we'll share it on our Facebook page probably in the next few days or so. I just need to remember how to do all that stuff. It's not, I know it's not too hard, but it'll take me a little while to figure it out, maybe a good 10, 15 minutes, and then it'll be available sometime soon. So
In the recorded version, Benedict Cumberbatch is going to be playing Adam Mahalski.
we can all hope. Well, thank you very much, Todd, for your presentation tonight. We all really enjoyed it. And it looks like we have a lot of good work ahead of us. Looks like you both, Stan and you, have done a lot of great work on this project already. And we are really looking forward to you getting to work here on the project at the Railroad Museum here in Carson City. And hopefully it'll be in operation sometime soon.
Well, and thanks everybody for your time. I really appreciate you spending some of your Thursday night with me and learning about the line, and I look forward to giving you more updates in the future. So I hope you have a good night.
All right.
Thanks very much, Todd.
Thanks, Jeff.
Bye.
Thank you.
Thanks, everybody.